Hi, I'm Alex and this short video is about air-to-water heat pumps for small businesses. I'm going to give you an introduction to the technology and how they could help your business reduce energy costs and cut carbon emissions. Air-to-water heat pumps are sometimes called air source heat pumps. They use refrigerant technology to move heat from the outside air of your building and use that heat to warm up water, which is then circulated through heat emitters such as radiators or perhaps an underfloor heating system. The obvious question is, how does that work when it's cold outside? Well, the refrigerant that's used within the heat pump has a boiling point that is lower than the outdoor temperature. Let's take a look at a simple diagram to see how it works in a bit more detail. Even when it's freezing cold outside, there's still some energy in the air that can be used to evaporate the refrigerant. To extract as much heat from the outside air as possible, air-to-water heat pumps use a large fan to blow air over a refrigerant-filled heat exchanger. This part of the system is called the evaporator. The refrigerant in the evaporator is then compressed using an electrically powered compressor. This increases its pressure and temperature, and the hot, high-pressure refrigerant gas is then passed over a second heat exchanger called the condenser. The hot gas gives up its heat and the heat is exchanged into a hot water circuit that passes through your radiators or underfloor heating system. The refrigerant then returns to the evaporator via an expansion valve, which turns it back into liquid ready to be evaporated again, and the cycle repeats. So this is an air-to-water heat pump that's been installed in an outdoor rooftop plant space of a commercial building. So it's often called an air source heat pump. And as you can see, it's got these two large grills with fans behind them, and they draw the air, the fans draw the air from the outdoor ambient air over the evaporator, which is its heat exchanger, and cause the refrigerant gas inside to turn to a vapour. Inside this box also, inside the unit, is the compressor and the condenser, which is another heat exchanger that allows the heat to be recovered and it's exchanged into these pipes, where it's sent into the building into underfloor heating pipework and radiator pipework to heat up the building. This particular unit supplied with electricity and produces hot water or heating hot water. All the components of the refrigeration system are inside the one box, so it's called a monoblock system. It's quite common also to have a split system where you have the outdoor evaporator and fans in the box outside, and you have the other components in another enclosure inside the building. And the two parts in the split system are connected together, not with water pipes, but with refrigerant pipes. So they have to be installed by a refrigeration engineer, rather than this system which can be installed by a heating engineer and an electrician. We've touched on how they work and what they look like. But what are the benefits of air-to-water heat pumps compared with other forms of heating? After all, a heat pump uses electricity to generate heat, so why not just use an electric boiler which does the same thing? Well, as we just saw, refrigerant is used to take heat out of the outdoor air and bring it indoors, so the system is mainly just moving heat from one place to another. In a properly designed system, an air-to-water heat pump can generate about 3 kilowatt hours of heat for every kilowatt hour of electricity it consumes. And this ratio is called the coefficient of performance, or COP. It's quoted on manufacturers' data sheets to indicate the efficiency of their products. So with a COP of 3, a heat pump will use about a third of the electricity that an electric heating system would use to do the same thing. But what about if you currently heat your building with gas? Well, gas is about a third or a quarter of the price of electricity, but because gas boilers are less than 100% efficient, you can still make a saving with a heat pump. The really big difference, though, is in the emissions. With more and more of our electricity coming from solar energy and wind, the carbon intensity of the electricity grid is rapidly falling. So heat pumps are a great choice to help reduce emissions, as well as our reliance on fossil fuels. So far so good, but what are the disadvantages of heat pumps? Because heat pumps work best when they're set up to produce relatively low water flow temperatures, they're best suited to well-insulated buildings. It's not advisable to use a heat pump in a drafty old building because it will struggle to heat the building up from cold and it just won't run efficiently. They also work best when they're operated for fairly long periods rather than short cycling them on and off like you would with a conventional boiler-based heating system. It's also important to understand that the COP quoted by the manufacturer is based upon very specific conditions. As you'd imagine, as it gets colder outside, the heat pump has to work harder to move the same amount of heat, so it consumes more electricity and the COP falls. The COP also depends on the temperature of the water you want to get from the heat pump. Heat pumps are ideal for applications with low temperature heat emitters such as underfloor heating because the heat pump doesn't have to work as hard to get better COP figures. But if you use ordinary radiators, you need higher temperatures to produce enough heat output. The COP could be much worse in those cases. So underfloor heating is the best option, but it can be very disruptive to install and to retrofit into buildings. You can compromise by using oversized conventional radiators instead. This way your heat pump can deliver its output at a relatively low water flow temperature, for example 50 degrees centigrade. If space is limited, you can also consider using fan convector radiators, which can be very compact. The other thing you have to consider is that you need a suitable location for the outdoor unit. It needs to be in a well-ventilated area. If you put your heat pump in a small enclosed yard, the area around it will gradually get colder as the heat pump extracts more heat from the air. Unless that air can be replenished with fresh outdoor air, the COP of the heat pump will start to drop. The last point to mention here is that if you're thinking of using a heat pump instead of gas or oil boiler, you might have to have your electrical supply upgraded. The cost of air-to-water heat pumps will vary depending on the capacity of the heat pump itself and if new heat emitters or an underfloor heating system has to be installed. They are more expensive to install than conventional gas boilers or electric heating, but they can be very cost effective to run. And if you're considering an air-to-water heat pump to replace electric heaters, then you could expect the additional cost to be recouped in electricity savings within just a few years. It'll take a bit longer if you're currently heating with gas, which is still one of the cheapest fuels. Heat pumps are generally very reliable, but they do require some maintenance. An annual inspection should be carried out by a heat pump engineer to make sure the system is operating properly and that the outdoor unit is free from debris that could affect its performance. The engineer will also check the system pressures, inspect the pipe lagging and run any required diagnostic tests on the heat pump itself. One final thing to think about when you're considering having a heat pump installed is the type of refrigerant gas it uses. Each type of refrigerant is given a global warming potential, or GWP figure. This represents their effect on the Earth's climate over a 100-year period, when compared to carbon dioxide. Carbon dioxide, or CO2, therefore has a global warming potential of 1. Some older refrigerants, such as R410A, have a GWP of 2000 or more. This means 1 kilogram of R410A has the same impact on the climate as 2000 kilograms of CO2. The most damaging of these refrigerants are being withdrawn and phased out in favour of some with a lower GWP. A refrigerant called R32 has become a popular alternative, but this still has a GWP of 700. Some systems use natural refrigerants such as ammonia, and these have a much lower GWP, but they still have to be carefully managed due to their flammability and toxicity. I hope you found this video useful. You can find more information about air-to-air heat pumps by downloading our fact sheet, or if you're interested in other technologies, we have more videos available. Thanks for watching.